Okay, can you hear me? Okay, good, thank you. All right. I wanted to start by talking about homework, and then we're going to transition into how the homework relates to the project. So in the, what do you want? Pardon me. We're going to go from the homework and how that relates to the project, because in the P3 deliverable for the project, you're going to do requirements and test cases. So we've talked about them before. Your previous homework was doing requirements and test cases. This one is about the UML. So let's talk about that a little bit. Before we start, for homework 3, I posted a solution. I think I'm going to modify it and repost it because I found a mistake in the last lecture. You are required to have a manager and a projectile. And for the manager in the main method, remember my advice, don't do all your work in the main method. So in the main method, if you read through those lines, set up the first iteration, fly the projectiles, print the distance between the hare and hound. Set up second iteration, fly the projectiles, print the distance between the hare and the hound. You should be able to, hopefully by reading those, and someone just coming to the software should know what's happening. And if you want to find out the details of what's happening, then you go to each of those methods. I'm not thrilled with the solution because I have set up first iteration, set up second iteration. It would be much better to have a generic just set up iteration. And I didn't like that solution either because it had this big giant long input list of parameters. And whenever you're making a method that has a big giant long list of input parameters, that's a signal that you're doing something not clever. Something's not right. So I just bit the bullet and made them all individuals. But that's bad too, because it's not generic. You want these things to be generic so they can be used over and over again. If we wanted to add a third iteration, I have to make a new method, and that's not good. So I'm not thrilled with the solution. And all I do to set up these, if once you go in here and look at how I set up the first iteration, I kept in my comments what the requirements were from the homework assignment. That's your choice. You don't need that. And set up the ground height, set up the initial angle. I did built a little random between method, which I think a lot of you guys are using. I think that was shown to you in lab. So I do set the initial angle, set the initial height, set the initial speed, and then I do hare.initialize projectile, and we're going to go look at what the projectile looks like in a minute. But it's got an initialization method in it. It's not a bad idea to have an initialization method for your classes. And then I do the same thing. I reset the angle, reset the height, reset the speed, and then I initialize the hound. So that's the setup, right? Then to do the flying, and again, I kept all these notes in here because these are, things being handed out to students. And so I thought that was useful. But I wouldn't have it if I was making this code normally. And basically it's a while loop as long as one of them hasn't hit the ground yet, right? Their Y location is above 0. And then you keep moving them. And you have to make some design decisions here. For example, and by the way, that's where the error is. I'll come back to that. For example, here I say hare.move projectile. Gosh, wait a minute. Should I have done it if the hare is above ground here, it moves? Or inside the move projectile method itself, it should be if I am above the ground, I move. Right? These are design decisions. Where does it belong? I don't know that you can make a strong case either way. I try to push functionality down into the objects themselves. So I let the hare and hound figure out if they're above ground still. I have a separate, when we go to look at the projectiles, you'll see I have separate move and accelerate methods. And the reason for that is each method should do one small job. So in my mind, moving is one thing and accelerating is another thing. So I kept them separate. You could have just a move method, and inside the move method, you do the acceleration. That's perfectly legit. However, in my mind, you're doing more things than the name of the method talks about, and that's a place where you can have confusion. If somebody wants to figure out, gosh, how does this thing ever accelerate? It's much clearer to have an accelerate method so they know where to go to look for that. And then at each iteration, I print out where they are, and I don't do any formatting, so it's just ugly as sin. I have a separate one, print distance between hare and hound. Okay, so now if we go to, oh, so where's the error? You see the error? It's here on line 100. What did I do wrong? In your homework, if you remember, you had to run 2 iterations. What was the difference between the 2 iterations?
The ground limit.
The ground height, right. So in the second one, the ground height is at 120, and yet I'm still checking against 0. So I let them go underground by 120 meters. That's no good. So that 0.0 is wrong. It should always be against the ground height. And having realized that, a better way to do it would be once the hare and hound hit the ground, like once the hare hits the ground, I should set its X and Y speeds to 0. And then I can always just check here rather than checking against the height, I should check against its speed. If it's still moving, move it. Otherwise, don't move it. So basically this while loop should be while at least one of them is still moving, keep doing this. And then when they both stop, then we're done. Okay, inside the projectile class, I think everybody has like an X location, Y location kind of attribute. And then I think most people do a gravity and a time step. And the place where people are going to be different is here. Remember, you're given initially an angle and a speed. And that's the speed along that angle. And I converted that to an X component of the speed and a Y component of the speed using cosine and sine. And the reason that, and so I set up my attributes to be X speed and Y speed, not angle and velocity. And the reason is I know how ballistic motion works. The X speed in ballistic motion never changes, and the Y speed changes based on the acceleration due to gravity. And so if I separate them out, I can always just keep the X speed the same and keep changing the Y speed based on gravity, and things will work out fine. If you do the angle and the speed method, you have to break them down into X and Y, change the Y value, and then put them back into a new angle with a new speed. So I can avoid that by just breaking up the 2 components. And then I have my initialized projectile method, and that's the one that just sets up the initial values when the thing's first fired. And again, remember what the manager computes is the initial angle, the initial speed, and the initial height. Okay, so I do the initial height. Well, X location is 0. Even though Java defaults that to 0, it's good to have that assignment explicitly because that's what people would expect, right? They would expect to see that the initial position has an X location and a Y location, and I'm writing for humans, not for the computer. So I would put it in there. Also, it's more generic. What if we wanted to change that someday? Then we already have a way to change it. And then the Y location is just the initial height. And then I'm taking that angle and speed, the initial angle and the initial speed, and I'm breaking it up into an initial X and Y speed component. And I do that, you know, the X component is just the speed times the cosine of the angle, and the Y component is just the speed times the sine of the angle. And then for move projectile, I made the same mistake again. If Y location is greater than 0.0, should be ground height though, right? That's wrong. I made a mistake there. If it's above 0, move it. Otherwise, don't move it. Oh, and by the way, if you ever end up below ground, I'm just going to default it back to ground. Now, notice what I did here. I did a simple movement. X location, that'll work out fine. With the Y location, during that time step, technically speaking, the Y is accelerating along there. So there is a slightly more complicated formula for what the distance is that you can use if you want to. I don't care either way. Whenever you're doing simulations, you have to make your own decisions as to what degree of error you can work with. And I'm going to just say, hey, it's a half a second time step. We're not going to get much error. So I'm just going to pretend that for that half a second, the Y speed is constant. That's false, but it's an approximation, and we're always making approximations in simulations. Is that going to affect things? Hey, do it both ways and see how bad it is. Maybe it does affect things. It's almost like the difference between compound interest and simple interest. You know, maybe it does affect things. Okay, and then as I said, I kept the acceleration separate from the movement, so I put the acceleration in. That's accurate. So I move, accelerate, move, accelerate, move, accelerate. And that's all the methods that I have in the projectile. The projectile is nice and simple. This was not originally in here, but instead of comparing against 0, I always should be comparing against ground height. So part of my initialization in the manager class should be to establish the ground height, and then I can always compare against the ground height. Okay, so I'll fix this. I made a note to fix this and repost it. Do we have questions about my approach or what anything's doing here? I put an announcement up last night that has these 2 files in it. Questions? Okay. Now for homework 6, this gets a little more complicated because now you have the hound and the hare. Rather than both being instances of the projectile class, you have differences in behavior. The hare behaves exactly as the original projectile did. The hound has the ability to move differently. And ultimately what we're going to do is have the human player determine the hound movement. So the way the hound moves differently, these are supposed to be simulating hot air balloons, and the way hot air balloons change their altitude is by burning fuel, making the air in the balloon hot, which makes it rise up. And so the hound now has the ability, instead of just following its initial trajectory, it has the ability to try to keep itself afloat because its job is to get as close to the hare as possible. So it's going to try to keep itself afloat until it lands next to the hare. And line 15 there says the hound AI shall attempt to land the hound as close to the hare as possible. And that turned out to be a problematical statement. That's why you see that note A there. You know, students were tearing their hair out trying to come up with really clever AI. Not the point of this, because we're going to replace that AI with a human player in the future. So your AI should be, the hound should randomly burn. That's a good solution. In fact, anytime you're doing AI, the first solution should be random behavior, because that way you get your system working and you can spend the rest of your life making smart AI. So start with AI that's random behavior. Okay, so make it as dumb as you want. You know, every turn it's got a 3% chance or a 5% chance or something like that of burning fuel. That's fine. And again, for the P3 deliverable, we're going to do requirements and test cases. So I want to use this example as a requirements and test case discussion. You had to do that in homework 4. For homework 5, you have to take this new configuration and create a UML diagram. And someone in Discord asked, what are we supposed to turn in? And I said, hey, look at module 6, slide 11, you need to turn in a UML diagram like that with some text describing what's happening, right? You should have some text that talks about what the, in this case, if I was turning this in, I would need a description of what the terrain class's job is, a description of what the sheep's job is, a description of what the dog's job is. Don't just plop figures down without telling the reader what they're looking at. So this is the sheepdog one that we've seen several times. The UML diagram, if you think about it for hare and hound, gosh, that's going to look awfully similar. Instead of generic animal, you have a generic projectile class. And that gets extended once to the hare and once to the hound. Even though the hare doesn't behave differently from the projectile, good idea to extend it. Why? You're thinking of the future. What if you need the hare to behave differently in the future? You've already got it built into the system. And instead of a game controller, you have a manager, and we don't have a terrain class. So your homework is going to look a lot like this. Okay, let's get back to this and start talking about some different requirements and requirement specifications. We have requirements here. Remember, a requirement specification is a very narrow testable thing. And so some of these are already so tightly written that they serve as requirement specifications. Okay, what would be some requirements that you might come up with here?
X and Y should never be negative numbers.
Okay, so it's going to be, let's be careful. Let's not use an and, because that's two things. It's going to be the hare X location shall never, we never want to say, we don't want to do the negatives. The hare X location shall be 0 or greater at all times. And then another requirement, the hound X location shall be 0 or greater at all times. That's going to be a hard one to write test cases for, by the way. You would really do that with more, you can do that more with analysis. Since the initial thing starts at 0 and your X speeds are always positive, then math says that you can never get a negative value out of that. It would be hard to coerce a negative value. I'm going to come back to the end of this.
Okay, I guess, could you do the boundary testing for the hare's initial height then?
Yeah, you can do boundary testing. And that's a tough one. And here's why. What was the initial height for the hare? The random initial
It's
height
between 400 and 1,000 meters, Professor.
Right. And I'm going to tell you why that's a hard one in a few minutes. So I like that you're throwing these out. This is good. This is the way you need to be thinking. All of these that are the boundary ones, they're going to be difficult to do. And we'll talk about why in a little bit.
So then would the hound's starting height be easy since it's just 600 meters? It's either true or not with a Boolean.
Right. And then how do you, because it's a fixed value, it's very difficult to come up with test cases for that. I'm not making this easy, am I? Here's a good one. We found a good one last the hound should be able to its creases over. Yeah, that's a good one, because that one has a nice beginning and end with really specific values. So I'm going to start with that one. Where's my, okay. always got issues with managing zoom on this screen. There we go. Okay. We're going to do that one in a little bit. So let's do requirement 1. It starts out as, how did it say it? I'm going to start out with this, the hound shall. By the way, these other ones that you brought up they're already in the probably a tight enough format. Whoops, where you can test them. Okay. Now, here's what I'm not liking. The hound shall have the ability to burn fuel, which increases current height by 11 meters. At this point, you have your design down, right? You've got a UML diagram. You've actually got methods defined. So you can actually tighten this up a little bit. How about if I replace this shall have the ability to, how about if I say the hound and now there's a question, am I getting too specific, right? You don't want your requirement specifications to impose a solution on you. And I've got elements of a solution in here, don't I? I've got a burn fuel method by name. I've got a Y location attribute by name. So there's some wiggle room here. Is that too specific? Yes and no. If you know that that's what your design is, and you remember you're already turning in a UML diagram for your project during the P3 deliverable, right? So you do your UML diagram first. Now you've got names of specific methods that you can impose requirements on. I don't think that's a bad thing. And what we haven't done is we haven't said how the burn fuel method increases the Y location by 11 meters. Oof. Okay, so there's a test case. Now it's a bad test case. What's bad about the test case? Besides the fact that I can't spell, what's bad about the test case?
Say it kind of like lacks context. Like you don't, but if you just read the test case, you don't really know like where that burn fuel method is.
Okay. Here's the question you ask yourself. If I gave this to a bunch of people, 10 people, 20 people, would they all perform the exact same actions? Would they all perform literally the exact same test? Would that be true here?
Ooh, that's a good question. I don't think so. I think
Yeah.
there's like ways to like, I think you could just increase Y location by 11 without implementing it inside the formula. And I think that would mess up the algorithm.
Okay. Is it a single puff of the method? Yes, an extended use, yeah. So how about this? Whoops. This is testable, right? Before, how do I know that it increased by 11? I don't know where it started from. You're not going to do it by looking at the screen. So instead, what do? It's your software. You can do whatever you want. You're building it. You can build a test method that literally injects the value 0.0 in for Y location, calls the burn fuel method, and then looks at the Y location attribute to see if it equals 11. And just for grins, see y equals 0.0 is bad because it landed, right? So maybe I should do that at 1.0. Now, unfortunately, there's really not very many good things here. What was the upper bound, by the way? Was it 2,500?
Yeah.
Is my math good? Okay. You can check boundaries. Now, this violates the rules of the game, by the way. Is that okay? This one probably only has like 2 test cases, by the way. This is probably okay, and here's why. You're going to have another method or another requirement that says thou shalt not go beyond 2,500, and basically you can test that one separately. And if you meet these 2 requirements at the same time, what your code will probably do, it'll be at 24.99, burns the fuel, you're at 25.10, and the other method will set it back to 2,500 or end the game, or whatever happens. Even if you're at 25.10, if the thing is the game is supposed to stop at that point, you can stop at 25.10 and the game stops. But that's a separate requirement, so it'd be a separate test case. So I wouldn't put hound location equals 25.10 and game stops here as an expected behavior, because that's not the thing you're testing. You're testing to see if the burn fuel increments your height by 11, and that's all you're testing. You have other requirements to figure out what happens as a result of that. Let me bring in these 2 that we were talking about last period. This is based on the winning and losing conditions. So if we look in the if we look in the original homework, it says the hound shall win when the distance between the hare and hound is under 7 meters. The hare shall win when the distance between the hare and hound is greater than or equal to 7 meters. So if I want to do this 2, and again, I did the same trick. I'm assuming that I know enough about my code to say that I have a determine winner method. And now I can make my requirement right down to the method level. Do you have to do that? You don't have to do that. And again, there's good parts and bad parts of that. The requirement specification should not impose a solution on you. And by naming that method, I've kind of imposed a partial solution because I'm assuming that that code has that. But if you're confident that your code has that, that's a fine way to do it, because you're not saying how the determined winner figures this out. It just says that it must figure that out. So we play the same game. And you always want to check the boundaries, right? So we're going to check it to hare has one is larger than or equal to 7 meters. What is this? whatever you're concluding with. Oh, okay. And then, you know, you check your boundary conditions. So we're checking for 7 meters, and then we're going to do, you know, check a little bit above that, and then check a little bit above that, you know. Or, you know, last period I even did that. Which, by the way, somebody lost, right? They're out of bounds. Okay, but that's a different requirement. Okay, so are these good test cases? 2.1, 2.2, 2.3. Is there anything wrong with those test cases? I think Kevin says no, but I think he was answering my first questions there. Right, you need exact values, right? So it should be set hair x location equals 7.0, y location equals 0.0, pound x location equals 0.0, y location equals 0.0. And then once you have that, I did what, 7.1 and 5,000. Notice I'm not going to test if it's less than that because that's the other requirement. So, oh gosh, ask yourself the question, if you gave this to 10 people or 15 people, would they all do the exact same thing? Would they all use the exact X and Y locations for the hare and the hound? In other words, are they running the exact same test? That's the question you need to ask yourself. And in this case, yes, they would. Now let me do let's do the other requirement. What was it? It has to be less than 7. So I'm going to do 5 and 0, and I'm going to do, I don't know, 6.9 and 0. Since you would probably have a method to determine the boundaries, would that affect the expected behavior even though that's not the requirement you're testing? And it depends upon how you constructed your code. So it may be that if somebody goes out of bounds, you have a completely different method handling that. And if you have a completely different method handling that, then it works fine here. If you are incorporating that boundary issue in your determine winner method, then you're right. Using 5,000 would not be a good test for this. It would be a good test for testing the out of bounds portion of the thing. Okay. Yeah, it's not easy, right? And the biggest lesson I want you to get out of this is this level of detail that you need to incorporate in your test cases. This, in the terms of the requirements, this real small specific behavior, atomic and testable. If it's not testable, it's not a good requirement. That's why we have to say exactly what happens. Notice I'm saying exactly what happens. I'm saying that this method shall print the hare has won. Oh, I better change that. The hare has won. That's the exact behavior in the requirement and its exact measurement. I have very specific behavior in the requirement again, and I have a very specific way to determine the conditions under which that behavior occurs. Writing requirements is always difficult. It's not something by the end of this semester that you're going to say, oh yeah, I can just whip those out in no time because they're so easy. They basically never become easy. They're intrinsically difficult. Writing the test cases once you have a good requirement isn't too horrible. The rule number one is be specific. So that, again, the question you ask yourself is, if I gave this to a bunch of people, would they all do the exact same thing? And when I worked at NASA, we had big test books. And the reason we had great big test books is because it was step by step by step by step. And it was literally press this button, green light comes on, verify green light came on, check, check, throw this switch. You know, literally one, you know, you've got a panel in a spacecraft of a bunch of switches and buttons and whatever. It's literally do this one action, do this action, do this action, so everybody knows the sequence. It's the same kind of thing here, but instead you're injecting values into your simulation, into your program, and then you're testing a method to see what it does with those values. Now, how do you make these values happen? Notice, by the way, this doesn't have really anything to do with user input. This isn't about, oh, I run it from the screen. Like, you know, for the burn fuel, it wasn't I click the burn fuel arrow key on the keyboard and I watch the balloon go up, right? That's not a good test. It requires a user. You don't need the user for it. It's your software. You can write test methods that literally set, you know, look at 2.1. You can write a test method that literally sets the X location and Y location of the hare and hound and then runs the determine winner method. You can build those test methods. Because it's your software, you can build it to do whatever you want. Volkswagen got in trouble because they built theirs to cheat, right? Okay.
I remember that.
Yeah. Now, what am I missing on the third one? I should have a 3.3 here. Can anyone think of what we're going to call the pathological case? What would be an unusual condition here?
Would it be considered unusual if you made it a negative or something?
Negative is good, right? And what happens before we get to negative?
Zero.
The game should have ended.
Right? What if they landed on top of each other? Never going to happen. Okay. The things that never going to happen are the things that ruin your software because they always happen. So you have to test for it. And then the other is, if you notice, right, you nailed it. The other thing here is all of my conditions are the hare further to the right on the gameplay board than the hound. And if someone wrote this software in such a way that they always subtracted the hare position minus the hound position, as long as the hare was to the right of the hound, you would be getting correct results from the determine winner method. But if the hare is to the left of the hound and further than 7 meters away, the hare should win. But if the determine winner method was written wrongly, then if the hare is at 100 and the hound is at 200, that's negative 200. Negative 200 is less than 7. Therefore, we're going to say the hound won, right? That's wrong. If it was coded improperly, that's wrong. So you do it where they're on top of each other, and then you make it where the hound, I want to say, make sure the hound is to the right of the hare, and we would put another one in here. Where the, let's get rid of that problematical 500. Where the hound is to the right of the hare, but the hare still wins. The hound is to the right of the hare. Oh no. There we go. Oh, I did it again though. Come on. There we go. Right. So you need to have it where you're testing all possible situations. All possible situations are the hare is to the right of the hound. The hare and the hound are on top of each other. The hound is to the right of the hare. Ideally, you test all. Now, again, in your code, I'm only asking for 5 requirements, and I'm asking for 3 test cases. I would stay away from random numbers. Now, let's go back to that, because that was one of the first things that someone brought up was the initial conditions that are random numbers. How can I test that? Like, let's say the hare shall have a random initial height from 400 to 1,000 meters. How can I test that? It's a trick question, by the way. It's tough to check. Here's the only thing you can do to test it. If your code doesn't have any recognition that those boundaries are broken, you cannot test it. So you have to ask yourself, well, the hare shall have a random initial height from 400 to 1,000 meters. Instead of testing it, you could prove it with analysis, which we don't discuss in this class, but that's a valid technique in industry. You say, look, you can read my method, you can look at my algorithm, and it takes 400 and it adds a random number between 0 and 600, and the biggest number I can get is 600, and 400 plus 600 is 1,000, so I can prove that I'm between 400 and 1,000. You can prove it analytically. But the only way you could prove it literally in software testing is if you built code where if for whatever reason you got something less than 400 or something less than 1,000, your code actually performed an action. Maybe that action is try again. Maybe that action is to crash. Maybe that bad action, by the way. Maybe that action is to just, if I get 1,020 meters, I'm just going to dump it down to 1,000. Then you can test it because you can inject numbers less than 400. You can inject numbers greater than 1,000 and then see how your code handles it, if it handles it the way you designed it to. But if your code doesn't even acknowledge out of bounds conditions, you can't test it. So those are not great. Anything with random numbers is really tough to test. I mean, technically what's happening, it says here the hare shall have a random initial height ranging from 400 to 1,000. Is that a bell curve focused around 700, or is that a flat line distribution? Or is it a distribution with a tail, right? It's a flat line distribution. So technically you'd have to prove you have a flat line distribution. Not easy, not easy. The way you do that is you do it like 1,000,000 times and do analysis on it. So these are tough ones. Okay, let's go back to the, okay, this looks pretty good, right? We've got hound to the right of the hare and hare to the right of the hound, and when they're on top of each other, and we're testing when the hare wins and we're testing with the hound wins. Have I left anything out? Are there test conditions cases here that we should include if we want to have a complete test suite? You know the answer is yes, right? Why would I ask? Can you think of what it is? Think of what the homework 6 says. Let me go back to that. Homework 6 has the addition of terrain. And what were all my tests have in common? What did I have the difference in? X values. What about Y values? Will that matter?
Yes.
Yeah. And now you have to go back and you read the requirement really carefully. Really carefully. What does it say? It says the hound shall win. Can I get that? The hound shall win when the distance is under 7. The hare wins when it's 7 or more. It did not say horizontal distance. It said distance. And you know,
So it applies to both.
pardon?
It applies to both vertical and horizontal.
Exactly, right. So you need to do some that include X distances only, Y distances only, and then at least one with a combination of X and Y, X and Y distance, you know, pick 45 degrees or something like that. So really we should have a test case in here that looks like, by the way, notice how you can make a ton of test cases. Now we should do, what am I supposed to do? I want the hound to win. So I want to have the hare at 1-1, and I want the hound at 1-8. No, that's going to be the hare, right? I want it to be 1-7. So now I'm doing the Y check. And again, if you didn't have the Y distance check in there, maybe somebody wrote the determine winner method and they always checked the X axis only. They only checked horizontal distance. All your test cases only check horizontal distance, but you've actually failed the requirement because you never tested it, right? So you don't know that you failed it, but the requirement is 7 meters is 7 meters, and it doesn't matter if it's horizontal, vertical, or something else. 7 meters is 7 meters, but you didn't put those test cases in. So you can see, you know, when you're writing software, you can write a lot of requirements and you can write a lot of test cases. I'm asking you for 5 requirements in your project, and each one for, you only need 3 test cases. Okay, quick questions before we go. Was this helpful? Are these talks helpful at all?
Yeah.
Yeah, I like the Friday lecture.
Good.
Yeah.
Now,
I'm just crying inside, don't worry.
the trick is, as you can see, learning to think at that detailed level. And the only way you learn to do it is to, you know, do it, you know, that's how you get good at everything, right? Practice, practice, practice. And what you'll find, write these things up and share them with other students, share them with the TAs, and get feedback, right? Because they're going to find holes that you didn't think of. Just like with my code that I, you know, rammed together last night, and I always tested against 0.0. Man, that's wrong, because that's not what ground level is. And here it's even worse because ground level now has those plateaus. Right. So just be aware, getting used to thinking in this really granular fashion does take time to develop that skill. All right, guys, thanks for being here. I will see you on Monday.
Have a nice day.
Thanks, you too.